Okay, so for this problem, the patient has a 60 PD, they're ortho at distance, they're 5 XP at 40 centimeters, and they're 12 XP at 40 centimeters if they're wearing plus 250 glasses. So it's asking for the calculated ACA, the gradient ACA, and the proximal convergence. Okay, so to solve this one, first we can get the calculated ACA by doing the same thing we've been doing. So circle, ortho line, convergence demand is 60 divided by 4, so that's 15. And then the distance lateral foria, it's ortho, so we don't draw another line. And then the near lateral foria is 5 XP, so that's to the right. Okay. And then, so I've been saying that to get the amount converged, we convert this to prism diopters. So 5 XP is 5 less than 15, so that's 10 prism diopters. We start at ortho, and then we converge 10 to get the 10. So total amount is 10 prism diopters converged. But another way of getting the same answer is by taking the convergence demand and subtracting everything between these two lines, the ortho line and the convergence demand line. So the convergence demand minus everything between the two lines and plus everything that's outside of the two lines. In this case, there's nothing outside of the two lines, but this 5 XP is inside the two lines. So we would do 15 minus what's inside the two lines. 15 minus 5 equals 10. So we end up with the same number. Okay, so now that we have that they converge 10 prism diopters, we divide 10 by 2.5 equals 4 over 1. That's the calculated ACA. Okay. And so for the next part, we're going to move on to step 9 that I wrote here. Ignore the Fourier line for the NLP and draw in the line for NLP with glasses. Okay. So before we do that, this patient, when they're looking at something 40 centimeters away, they have to accommodate 2.5 diopters. But if they're wearing plus 250 glasses, that relaxes the accommodation. So if they're relaxing their accommodation by 2.5, and they're looking at something that requires 2.5 diopters of accommodation, they're not accommodating at all. So the amount they converge is just their proximal convergence. There's no accommodative convergence involved. Okay, so their NLP is 12 XP at 40 centimeters with plus 250 glasses on. So if it's 12 XP, it's more to the right than this 5. So 12 XP right here. And then remember, we're ignoring this line for now. Okay, so again, to calculate the amount converged, we can convert to diopters. So 12 XP is 12 less than 15. So it's 3. So ortho to 3 is just 3. Or we can do 15 minus what's in between these two lines plus what's outside of the two lines. But the only thing that's inside of these two lines is this 12. Remember, we're ignoring the 5 XP for now. Okay, so then we do 15 minus 12 equals 3. So we end up with the same thing. And then, so we know that they converge 3 without accommodating. And so that's our proximal convergence. All right, so we figured out the calculated ACA and the proximal convergence. So all that's left is the gradient ACA. So the gradient ACA is just how much the patient is affected by glasses. So in this case, all we have to do is find the distance between their calculated ACA and their proximal convergence. Because we know without accommodating, they converge 3. And then with the glasses on, without the glasses on, they accommodate 2.5 diopters and they end up 5 XP. So 3 of the diopters that they converge are just from proximal convergence, and the rest is from their accommodative convergence. So what we can do is just find the difference between these two lines. So if we do what we did before, we convert them to prism diopters. So 5 XP is 5 less than 15, so that's 10. 12 XP is 12 less than 15, so that's 3. So from 3 to 10 is just 7. So the amount they converged once they removed the glasses is 7 prism diopters. Okay, and so the glasses were 2.5. So we divide 7 by 2.5, and we end up with an ACA of 2.8 over 1, and that's the gradient. Okay, so I'll say that one more time. You find the calculated ACA as usual. You find the proximal convergence by using the Fourier with the glasses on. And the difference between the two Fouriers is the number you use to calculate the gradient ACA.